In this question, we're told the nth term of a sequence is Tn is equal to ln a to the power of n, where a is greater than 0, and a is a constant. For part A, part 1, we need to show that the first, second, and third term are in an arithmetic sequence. Okay, so for this one, let's just start by subbing in 1 into this. So T1 will be equal to ln a to the power of 1. Using laws of logs then, the 1 can come down, so that's equal to 1 ln a. Second term then, so ln a to the power of 2, so putting in 2 instead of n. Laws of logs then, the 2 can come down, so then we have 2 ln a. Same for the third term, so ln a to the power of 3, so we have 3 ln a. So we can see now that our sequence of ln a, 2 ln a, and 3 ln a is an arithmetic sequence with ln a being added every time. So the difference is ln a. Now, for the next part then, we need to prove that the sequence is arithmetic and find the common difference. And now remember, with arithmetic sequences, for the common difference, you'd have Tn minus 1 will be equal to our difference. So our Tn is equal to ln a to the power of n. We can bring the n down, so that'd be equal to n ln a. For Tn minus 1 now, that'll be ln a to the power of n minus 1. Bring that down, so we have n minus 1 times ln a. Now I can expand that out to make it n ln a minus ln a. Now if we go back to the start here, and if we subtract them, so Tn is n ln a minus now n ln a minus minus ln a. So n ln a minus n ln a plus now ln a. So the n ln a is cancelled. So we're left now with ln a, which is our difference, okay, from the first part. So we've proved that we have an arithmetic sequence. Also, because we're getting a constant at the end of it, so ln a is a constant, so that means we've proved that it is an arithmetic sequence. Okay, part B now, we need to find the value for a for which the first 100 terms adds up to 10,100. So the sum of the first 100 terms, so I'm going to write down the sum formula. So sum of n equals n over 2 times a plus n minus 1 times the difference. Okay, we're being told now that this equals 10,100. And we need to find the value of a for which this happens. Now you can see I've written out the first 3 terms, which we got from the previous part of the question here. So let's start using those now. So we know that n in this one is going to be 100 over 2. So 2a, so 2 ln a, plus then we're going to have 100 minus 1 times ln a. And all this now is equal to 10,100. Okay, so I'll have 50 now, 2 ln a plus 99 ln a equals to 10,100. Let's divide now by 50. So 10,100 divided by 50. So I'm left now with, so 2 ln a plus 99 ln a, that will be 101 ln a equals to 202. Dividing now by 101. So I'm left with ln A is equal to 2. Now we need to find A, and if I bring the ln to the other side, the inverse of ln A is an E, so that means A is equal to E to the power of 2. So putting that into the calculator, and that gets 7.389. And there's our value of A. Okay, for the next part then, we need to verify that for all values of A, the first 10 terms added together plus 100 times the difference is equal to the 11th to the 20th term, all added together, where D then is the common difference of the sequence. Okay, so firstly, let's get the sum of the first 10 terms. So I'm going to write out the sum of formula again. So sum of n is equal to n over 2, 2a plus n minus 1 times d. So the first 10 terms, we'll have 10 over 2 plus 2 then. So remember the first term was ln A plus then n minus 1, so that'll be 10 minus 1 times the difference, which is ln A. So we'll have 5 now, 2 ln A plus 9 ln A. So that'll be 5 times 11 ln A. So that is 55 ln A. And don't forget to add in plus 100 times the difference. And the difference is ln A, which we worked out earlier. So this works out now as 155 ln A. Okay, so that's the first part. Next part then, so we need to work out the sum of the 11th to the 20th term. So what I'm going to do for this one, I'm going to work out the sum of the first 20 terms and then subtract the first 10 terms away from it, because I already have that, and that is 55 ln A. Okay, so let's get the sum of the first 20 terms. So that would be 20 over 2, 2 times ln A, plus 20 minus 1 times ln A, because that's the difference. So I'll have 10 now, 2 ln A, plus 19 ln A. So 21 ln A, which then is 210 ln A. Now remember to subtract from this the sum of the first 10 terms, which we have. So I have 210 ln A minus sum of the first 10 terms, which is 55 ln A. And when we do 210 minus 55, that then gives us 155 ln A. So we can see there that they are the same. So we have verified it. Okay, and there's the question done. Any questions, please leave in the comments. Thank you.